Hello all and welcome to a new video on IGCSE Physics Classified. In this video, we shall be dealing with the equation W equals mg. W stands for weight, which is the pull of gravity on an object. M is for mass, the mass of an object. And G is for the gravity or gravitational field or gravitational acceleration, right? So we'll just tackle different questions dealing with a combination of these three variables. So which expression is used to find gravitational field strength G? We just said W equals mg, so G equals W divided by M. And the correct choice here would be choice D, weight divided by mass. A body of mass M has weight W in location where the gravitational field strength is G. Which statement about these quantities is correct? So again, let's write W equals mg. So M and W are both forces. This is not true. W is a force, but M is not. M and W are both vector quantities. Again, not true because M is a scalar. It does not have a direction. There is no such thing as saying I have a mass of 50 kilograms to the right or to the left, for example. C says M and W are related by the equation W over M equals G. So if we rewrite this equation, we can get W over M equals G. So C is correct. D, M and W have the same unit. No, they don't. M is measured in kilograms, while W is measured in newtons. So the correct answer here is choice C. A person steps onto bathroom scales. The bathroom scales record both mass and weight. Which row shows the readings on the scales? So first of all, the mass has to be measured in kilograms. So this is automatically discarded, and this is automatically discarded as well. Now, we're between choices B and C. And we should know that the weight is 10 times the mass. So W equals mg, which is approximately equals to 10m. So the correct choice here would be choice B. An object has a weight of 7,600 newtons in a gravitational field of strength 100 newtons per kilogram. What is the mass of the object? So W equals mg, 7,600 equals M times 100. I can just divide to get M. So M is 7,600 divided by 100. And the correct answer here would be 76 kilograms. So the correct choice here is choice A. Which object has the greatest weight? So in order to calculate the weight, we multiply mass times gravity, M times G. So the weight here is 150, 10 times 15. For the second one, the weight is equal to 15 times 13. So let me just do that on the calculator really quickly. So we're trying to calculate here 15 times 13. And this gives us 195. An object of mass 20 in a 9 Newton kilogram gravitational field. So 20 times 9 gives us 180. And finally, 50 times 3, which gives us 150. So the greatest weight here is choice B, 195. An object has a mass of 50 kilograms. The gravitational field strength on Earth is 10 Newton per kilogram. The gravitational field strength on a distant planet is 4 Newton per kilogram. What is the weight of the object on Earth and what is the weight of the object on the distant planet? So basically, again, we're trying to do W equals mg, but we have different g's this time, one for Earth and one for the other planet. So First of all, when we're asking about weight, we don't really care about kilograms. We don't care about the mass. He's asking about the weight. So without even any calculations, you can automatically disregard anything that says kilograms. And we're left with either B or D. So if it has a mass of 50 kilograms, we of course deduce that the weight is 50 times 10 on Earth. So that's 500 newtons. And for the other planet, it would be 50 times 4, which would confirm our answer, 200 newtons. So the correct choice here would be choice D. 4 identical steel blocks weigh 120 newtons in total. The gravitational field strength G is 10. What is the mass of one steel block? One of the oldest tricks in the book that Cambridge people love to use is to use numbers written as letters. So you're usually just automatically encouraged to look at the numbers. In your brain, automatically, you just want to look at the numbers and figure out what variables you have to do an equation of some sort. So what they do instead is they give you quantities, but written in letters. So watch out. Here we have 4, and this is a very important piece of information. And their weight in total is 120 newtons. So we can get the weight of one block as 120 over 4, which is 30 newtons. If you do not divide by 4, of course, you're going to get an incorrect answer. So this is one trick here, because they asked for the mass of one steel block, not 4. So to get the mass now, we just do 30 divided by 10, because M equals W over G. So 30 divided by 10, which is 3 kilograms. And the correct choice here is A. Moving on, an empty beaker is placed on a top pan balance. Some water is now poured into the beaker. What is the weight of the water? So first we need to get the mass of the water, and the mass is the difference between the two masses before and after adding the water. So we're going to subtract. We're going to say 0.106 minus 0.062. We're basically removing the mass of the beaker just to calculate the mass of the water itself. Excuse me. This is equal to, wait, let me do it on the calculator really quickly. So 0.106 minus 0.062. And that gives us 0.044 kilograms. Then the weight is the mass multiplied by gravity. So I just basically multiply this by 10, and this gives me 0.44 newtons. Hence, my correct answer here is D. The graph shows how weight varies with mass on planet P and planet Q. An object weighs 400 newtons on planet P. The object is taken to planet Q. Which row is correct? So you have to remember that the mass of the object is the same on both planets, because the mass depends on the number of molecules inside the object. However, the weight is going to vary from one planet to the other depending on the gravitational field strength. And this is what we're going to use to solve the problem. Now, we have a graph that shows the relationship between mass and weight on the two planets, and we're given that the object weighs 400 newtons on planet P. So at the weight, which is at the y-axis, we look for 400 and we see where it intersects the graph. And we find that it intersects the graph at a mass of 40. So the mass of the object is 40. To get the weight, we just see for a 40 kilogram object, what would the weight be on planet Q? So we go back up, but this time we're intersecting the graph of planet Q. And the answer is 200, hence the correct choice is choice A, mass of 40 and weight of 200. 4 identical steel blocks are placed on a balance. The reading on the balance is 220 newtons. What is the mass of one steel block? Again, they use the trick of using letters instead of numbers. So you have to first divide the weight by 4. 220 divided by 4, which is 55. And then W equals mg. So 55 equals m times 10. Therefore, the mass is equal to 5.5 kilograms. And the correct choice here would be choice A. The acceleration of free fall on Mars is 3.7. What is the weight of a 100-gram mass on Mars? So bear in mind that the acceleration of free fall is another way of saying the gravity. Gravitational acceleration, gravity, gravitational field strength, acceleration of free fall. These all mean the same thing. This is the value of G. We want to get the weight given that the mass is 100 grams, but we have to convert it first to kilograms. So the mass would be 0.1 kilograms. So the weight is going to be 0.1 multiplied by 3.7. And the correct answer here would be 0.37 newtons. And therefore, the correct choice is choice B. A helium balloon is tied to a top pan balance. A metal block of mass 100 grams is placed on the balance. The reading is 91. Which statement can be deduced from this experiment? So the metal block has a mass of 100 grams. So we should assume that without the balloon was not there, the reading here would have been 100 grams. However, with the balloon, the reading is 91 grams. So the mass decreased in a sense. And this is, of course, not true. It's not that the mass decreased. It's that the balloon is sort of creating an upwards force that is lifting the platform up in a sense. It's just exerting an upward force that makes it appear as though the block has a smaller mass. So the correct statement here is actually, excuse me, give me a minute. So the correct statement here is probably statement D, but let's do the calculation anyway. So 91 grams, first convert to kilograms. So you get 0.091 kilograms, and then convert to newtons by multiplying by 10. So you get 0.91 newtons. So 91 grams are equivalent to 0.91 newtons. And this tells us that the resultant downward force on the pan is 0.91 newtons. As I explained earlier, this is due to an upward force exerted by the balloon that decreases the resultant force. So you have the weight downwards and an upward force, and then your resultant force is basically W minus F. So the correct choice here would be choice D. And this brings us to the end of our video. I hope this was useful to you. Thank you for joining in.